An important kind of simplification of expressions with surds in is called rationalizing the denominator. If we have expressions such as in these examples where there are surds on the denominator, those expressions are difficult to work with and don't look tremendously attractive. The idea of rationalizing the denominator, as its name suggests, is to rewrite these fractions so that the denominator is a rational number, preferably an integer. Let's look at these examples and explain how we can do this. In the first case, we have 3 divided by root 5. Now we want to rewrite this so we don't have a surd on the denominator, but we don't want to change its value. What we can do is multiply by a fraction, and so that we don't change the value of the quantity we're looking at, this will have to be a fraction with the same number on the numerator and the denominator, so that effectively we are multiplying by 1. In the case where we just have a surd on the denominator, the fraction we multiply by has that surd, both numerator and denominator. So in this case, we'll multiply by root 5 over root 5. Doing the fraction multiplication, we have 3 root 5 on the numerator and root 5 times root 5, which is 5, on the denominator. We have rationalized the denominator of that fraction. It's also completely okay to write that as 3/5 of root 5. Either of those forms is an acceptable final answer. In part B, we can't do exactly the same thing because we don't just have a surd on the denominator, we have an integer subtract a surd. In cases like this, the thing to multiply by is the same two terms, the 2 and the root 3. What we need to do is to change the sign of either one of them. By which I mean we could have negative 2 subtract root 3. We've left the sign of the negative root 3 alone but changed the positive 2 to a negative. Or we could have positive 2 plus root 3 because we've changed this sign from a negative to a positive. And having decided that's what we're going to multiply by, we will need the same thing on the numerator. Now let's do that multiplication. On the numerator we will have 6 times 2, which is 12, plus 6 times root 3, which is 6 root 3. On the denominator, it will be easier to think of this as multiplying these two bracketed terms together. We will have 2 times 2, 4. We'll have 2 times root 3, which is 2 root 3. We will have negative root 3 times 2, subtract 2 root 3, and we'll have negative root 3 times root 3, which will just be negative 3. Now, you can see that the 2 root 3 and the negative 2 root 3 are going to cancel out, leaving us with 12 plus 6 root 3 divided by 4 subtract 3. And 4 subtract 3 is 1, so in this case our final answer is just 12 plus 6 root 3. It won't always be the case that the denominator turns into 1 and we can therefore ignore it, but whatever it is, it will now be a rational number. In part C, we can try something extremely similar. Just because the two terms in the denominator are both surds doesn't mean we can't pull the same trick. So this time we'll multiply by root 3 subtract root 7, and we'll have to do the same on the numerator. What do we get? 2 root 3 subtract 2 root 7 divided by root 3 times root 3 is 3. Root 3 times negative root 7, subtract root 3 root 7. Root 7 times root 3 will be adding a root 3 root 7, and root 7 times negative root 7 will be subtracting 7. So we still have 2 root 3 subtract 2 root 7 on the numerator. In the denominator, these two surd pieces will cancel out. We will have 3 subtract 7, we'll have negative 4. And we can tidy that up finally into root 7 subtract root 3 over 2. We've cancelled a 2 from the numerator and denominator and also multiplied both numerator and denominator by negative 1 to make it a bit more attractive. Our last example looks much more complicated. we are asked to rationalise 4 over 1 plus root 5 times 3 subtract root 5. Is there any new trick we can use here? Well, no. All we have to do to begin with is to expand the bottom before we start rationalising. So we will have 4 on our numerator. 1 times 3 is 3. 1 times negative root 5 is negative root 5. 3 times root 5 is 3 root 5. Root 5 times negative root 5 is negative 5. So what do we have? 4 over, now we have 2 root 5s, subtract 2. We can simplify that slightly more before we go any further. We can write this as 2 over 2 multiplied by 2 over root 5 minus 1, and therefore we just have 2 over root 5 minus 1. Now it is this final fraction that we are going to rationalise. So this is equal to 2 over root 5 minus 1 multiplied by root 5 plus 1 over root 5 plus 1. On the numerator we will have 2 root 5 plus 2. On the denominator we'll have root 5 times root 5, which is 5. We will have a plus root 5 and a negative root 5, which will cancel out. Once you are more familiar with these questions, it's perfectly acceptable just to not bother writing those two terms down. But we will have the negative 1 times 1. We'll have a negative 1. So we have 2 root 5 plus 2 divided by 4, which simplifies to root 5 plus 1 over 2. An important thing to realise throughout the whole of this topic is that most modern calculators will simplify these expressions for you automatically. If you just type in the question, it will give you the answer, and if it needs rationalising, it will do that for you as well. This is a part of the course where you will be expected to show your ability to understand and use these methods. So make sure you show a lot of working, all the steps that you think are necessary. Don't just rush to the answer by typing it into a calculator. Of course, you can always do that to check that you've got the right answer, but don't rely on it as the only thing that you do. Show some working as well.